All right, 7.3, we're going to talk about two different ways that you'll have systems presented to you. Do you see the difference between the top example and the bottom example?
Yes.
Okay. The top example you're going to use, it's called Gaussian Elimination, and I'll show you that in a second. But notice you have your three equations. All of your variables are lined up on top of each other. It's the first thing you need to do in order to solve them. Ashley, pay attention, please. But you have x's, you have y's, you have z's, and then you have equals your constant. The second thing is called, or set of equations, is called row echelon form. And they call it kind of like a stair-step pattern, because it looks like a stair-step. When it is in this form, would you guys be able to solve this system of equations? How would you do it? Plug in z to the second equation, right? Then plug in y and z to the top one and find. Now, when you write your answer is going to be written in what's called an ordered triple. All that means is you're going to have an x value, a y value, and a z value. Instead of an ordered pair, we had just x and y. Now you'll have an ordered triple, so you have three answers, x, y, and z. Does that make sense? Yes? Mm-hmm. Okay, so let's look at this example. On your WebAssign, you'll have questions like this. On your test, you'll have a question like this. You need to make sure you understand how to show your work. I'm not asking you guys to write a million extra things or anything like that. But what you would do here is you would say, okay, I have my z. My z is what number? 2. So I'm going to take 2 and I'll put it right there. So you would show me your work by saying y plus 4 times 2 equals 7. Yeah? Mm-hmm. So I have y plus 8 equals 7. So y equals what? Negative 1. You guys good with that?
Yeah.
What's up? Seriously? Okay, so your back substitution means you're just kind of like working backwards. They're going to tell you that this variable z is 2. So in order to find all the other ones, would it make sense to plug z in here to then solve for y? Or would you put it in here and then you'd have 2 unknowns? Yeah, so you're just going to plug it right in here. So when you solve this, you get y equals negative 1. So now that you know that y equals negative 1, what do you do with z and y? Plug it in the top one. So you have x minus 2 times negative 1 plus 3 times 2 equals 9. So x plus 2 plus 6 equals 9. X plus 8 equals 9. So x equals what? 1. And how would you write your answer? 1 comma, 1 comma, negative 1 comma, 2. And before you move on to your next problem, can you figure out real quick that you're right or not? Just plug it in. You don't have to show me the check. You can just plug it in your calculator. But when you get your ordered triple, you should be able to plug them into all of the equations, and they all work out. Make sense? Yeah? Okay. We like it when it's set up. That's super easy. This is the next way that we're going to solve. And I'm not going to go through, you guys can read and understand that. But you're going to go from your 3 linear systems that are written xyz equals, xyz equals, xyz equals. And you're going to get it into the row echelon form. So it says z equals a number, and then you can do back substitution. It's a little bit of process, and we'll get there in a second. But if you have a question like this on WebAssign, I'm showing you this because I'm going to be very particular on this. How do you know if this is a solution to the system? You plug it in and the equation's true. I understand you all can sit here and plug it in on a calculator. I want to see that you understand that you're plugging in 1 for x, that you're plugging in 0 for y, and that you're plugging in 2 for z. That's all I need to see. Now you guys can work this out. What's 1 minus 3 times 0 is 0? So 1 minus 0 is 1 plus 2 is, so this one works. Then your second one, you're going to say, okay, 2 times 1 plus 0 minus 5 times 2, does that equal negative 8? Well, what's 2 times 1 plus 0 minus 10? So you're good, right? Make sure you check all 3 because there could be a situation where it works in 2 but not the third one. So now I say 1 minus 0 plus 3 times 2, does that equal 7? Well, 1 minus 0 is 1. Plus 6 is, there you go. I need to see that you show me that step that you know what numbers to plug in where. Got that? Okay. Moving on. I'm going to go through this one quickly because this is fairly easy. But we're going to solve using back substitution. Back substitution. So I'm going to take 8 and I'm going to plug it in where? So I have y plus 2 times 8 equals 6. Y plus 16 equals 6. So y equals what? Negative 10. All right, now I know what y is. I know what z is. I'm going to take those two and I'm going to plug it into the top. So 2x minus y is negative 10 plus 5 times 8 equals 24. So I have 2x plus 10, yes, plus 40 equals 24. 2x plus 50 equals 24. What do I do to both sides? Subtract 50. 2x equals negative 26. Divide by 2. And x equals what? Negative 13. How do I write my answer? Negative 13, comma, negative 10, comma, 8. It's, no, for x, y, and z. What you got for x, what you got for y, what you get for z. This is my x value, my y value, and my z. Everybody see that? All right. As we move along and these get a little more involved, I need everybody off of whatever you're doing. You've got to pay attention to this. This can get very confusing. I was going through your notes this morning during planning, and I kept making dumb mistakes. I could not figure out two of the problems. I'm like, what am I doing? It was just a sign error. But you'll see how easy it is to make a mistake, and it's really hard to find your mistake. So I need you guys to stay organized and pay attention, all right? Dale, are you with me? Okay. These are the steps. If you don't recall or memorize or understand what I'm saying, these are the steps how to use the Gaussian elimination. This is what I'm talking about. This is not set up where you know what z equals, you plug it back in to find y, then plug it back in. We're going to set it up that way so you can. The first thing you need to do is make sure your top equation has a positive 1 as the coefficient for x. Does it right now?
Yes.
Yes, okay. Just say this was a 2x. Just say that that happened to be a 2. All right? You could look at this and say, okay, I have to have my first equation to be a positive 1x. Well, which one could I possibly manipulate very easily to make it a positive 1x? The second one, right? I would divide everything by negative 1, and then that would become my top equation. But sometimes it's set up nice and easy for you, like it's already like that, like it is now, so that's cool. So what you're going to do is you're going to take that first equation that has a positive 1x coefficient, and you're going to just rewrite it. So you have x minus 2y plus 3z equals 9. Super important that you rewrite it correctly, that you have the signs right, all that good stuff, okay? All right, next step. You're going to take the first two equations, and you are going to eliminate the x variable. This one happens to be set up nicely that it just eliminates without even having to do anything, right? Agreed? I don't have to multiply by anything. I can just add down, and when I do, the x's cancel out. So I'm left with what? Negative y plus 4z equals 7. There's my second equation. Oh, yeah, my bad. Sorry. It's y, just y. Thank you. So you have y plus 4z equals 7. All right, now we're going to do a little bit of work. It's not anything you guys can't handle, but you just have to pay attention to what you're doing. We want now our last equation to say what letter? I have x, y, z in the first one. The second one I have y, z. What do you think I want the last one to say? Z. Just z. So you're going to use a combination of the first and second, and first and third, second and third. Meaning you're going to take the first equation and the last equation. So we're going to say x minus 2y plus 3z equals 9. And then 2x minus 5y plus 5z equals 17. We're going to first eliminate the x's. If I'm going to eliminate the x's, what am I going to multiply the top equation by? 2. What kind of 2?
Negative.
Negative 2. Okay, good. So agree. Do you guys agree with me? This becomes negative 2x plus 4y minus 6z equals negative 18. Okay? So that's not there anymore. So that cancels out. I have y minus z equals what? What's 17 minus 18? Negative 1. Christian. I thought I wrote it. I'm sorry. Negative y minus z equals negative 1, right? So now what do you guys think I do?
You put the second answer.
I put the second one, this green one right here. I'm going to use this one because I'm trying to eliminate what letter? Y. I just eliminated the x's. Now I'm trying to eliminate the y's. So now I'm going to combine those two. What happens to the y's? So I get negative z and a positive 4. So it's 3z equals how much? 6. Then what? Divide both by 2. So z equals 2. Guys, have I solved this? No. Your answer should be an ordered triple. What you get for x, what you get for y, what you get for z. But can I now go about solving it? Yes. Now I use my back substitution. So I'm going to say, all right, well, I know that z is 2. So I'm going to take that, put it right there, right? So I have y plus 4 times 2 equals 7. Y plus 8 equals 7. So y equals what? Negative 1. And then I'm going to put in the top one, I'm going to say, okay, well, x minus 2 times y, negative 1, plus 3 times 2 equals 9. So x plus 2 plus 6 equals 9. X plus 8 equals 9. So what does x equal? 1.
Can't you just plug it in to the same equation, though, y plus 4z equals 7, but just don't plug in the z? And just plug in the y to find the z? Oh, wait, no, you're solving for x.
Yeah, we're solving for, yeah. So what's my answer? Yeah, I mean, you're just plugging it back in. What's my answer? 1 comma, negative 1 comma 2. All right, guys, there's lots of room for error here. I'm going to be looking ultimately that you get the ordered triple. But if you don't show me all of your work and it's not some sort of organized pattern, I am not going to search through to try and find points to give you. So stay as organized as possible. If you want to bring different colors, you want to do anything like that, that's fine, but you need to stay as organized as possible. What can I do with these answers that I just found? I can plug them back in and make sure that I'm right. Okay? You guys are going to need a lot of practice on this, I understand. Let's do this one together. What's the first thing I need to do?
Have your first one.
Okay, we're going to eliminate the x's, but my first top equation should have what as its coefficient?
X.
Positive 1x. Is it a positive 1x right now?
No.
No. So what am I going to make my first equation?
X minus
The second one. This first equation is going to be x minus 2y plus z equals 8. I want my second equation to have what two letters in it? Y and z. And I want my third equation to have what letter in it? Z. So now we're just going to go through the process. It's a pain in the butt. I understand that, but it's nothing you guys can't handle. 2x plus y plus 3z equals 9. X minus 2y plus z equals 8. What am I going to multiply? Bottom by negative 2. I want to get rid of the x's first. So I have negative 2x plus 4y, right? Minus 2z equals negative what? 16. Make sure all of your math is correct, because if you make one tiny mistake, a plus or a minus, it's going to mess everything up. So now if I add down, my x's cancel. I'm left with what? 5y plus z equals negative 7. So I'm going to write 5y plus z equals negative 7. Was that it? Check again, make sure. Okay, so I want my second equation to have two letters, y and z. What do I want? What do I want my third equation to say? Just z. So that means I have to do two sets of elimination. I got to first take the first equation and the last equation and eliminate what? The x's. Okay, let's eliminate x's. What am I? I'm going to multiply the top by what? Positive 2. Okay, so I'm going to have 4x. Let me use a different color. 4x plus what? Actually, you know what? Let's go back. Just so I don't confuse you guys. Let's use our top original. That remember we switched? We moved this one up here. Let's just keep it like that. So we'll have x minus 2y plus z equals 8 minus 4x plus 3y plus 2z equals negative 4. Let's eliminate the x's. What am I going to multiply top by?
4.
So I have 4x, then what? Minus 8y plus 4z equals 32. Okay. So if I eliminate, I have negative 5y plus 6z equals what? 28. Good. All right. Now I needed to say just z equals. So what should I do? With the second one, right? This 5y plus z equals negative 7. Well, what's negative 5y and a positive 5y? They'll cancel out nice and pretty. What's 6z and 1z? So 7z equals 21. So z equals 3. So z equals 3. All right, now that I have my equation set up in row echelon, all of that work, now what do I do to find my ordered triple? Just plug it back in. So if I plug in 3 right there, I have 5y plus 3 equals negative 7. So what? Minus 3 from both sides. 5y equals negative 10. So y equals, what is it? Negative 2. Good. So I know what z is. I know what y is. Yes, ma'am.
If you plug 3 into, go down, the 5y plus 6 equals 28, would you get the same thing? No, you have to do
It's got to be, because that's only half of the product. This is your second equation, not this. This is just our journey to get to the third equation. That's why I rewrote it up here. Yeah. Yeah, I can't give you a bunch of these because it'd be super long. So where was I? I need to find x now, correct? Okay, so we're just going to plug everything in. I have x minus 2 times y. What do we say y was? Negative 2 plus 3 equals 8. Say it again.
It's negative 3. Oh, no.
Did I mess up? So I have x plus 4 plus 3 equals 8. X plus 7 equals 8. What does x equal? So my ordered triple is 1, negative 2, 3. This is not terribly hard. It's just a pain. It's a lot of work. And if you don't stay organized, it can get really yucky. Another one, because you will have some guys that don't end up all pretty and nice and even whole numbers. So the first thing I need to look for is what? All right, my first equation, I needed to start off with a positive 1. Yes?
Yes.
Okay, so I'm just going to rewrite it over here as x plus y plus 3z equals 7. So my next equation, I want it to say what? What does my second equation need to have in it? Guys, what does the next equation need to be?
Needs to be y.
Y and z. So we're going to take the first two. X plus y plus 3z equals 7. and 2x minus 4y plus z equals 7. How can I combine these?
Multiply the top by 2, or -2.
-2, okay. So negative 2x, negative 2y, negative 6z equals negative 14. Agreed? Did I do all the math right? Yeah, we're good? Okay, if I combine, I have negative 6y minus 5z equals negative 7. Yeah? Okay. So, negative 6y, is it minus 5z? Minus 5z equals negative 7. Was it? Okay, now I need the last one to just say z equals. So what's the process? What do I do? What do I do? Okay, first and third. So I have x plus y plus 3z equals 7. And the third is 3x plus 5y minus 4z equals negative 6. So if I want x's to cancel out, what am I multiplying? Okay, at the top by negative 3. So negative 3x minus 3y, right? Minus 9z equals negative 21. This is a 5. Okay, that's not there anymore. So my x's cancel out. What's 5 minus 3? So you have positive 2y minus what? 13z equals negative 27. It's still hard to see, but okay, so I got that now. Now what do? I'm trying to get my last equation to say z equals the red one. Okay, the red one that we rewrote. So now I'm going to put underneath here negative 6y minus 5z equals negative 7. Agreed? Okay, what am I multiplying the top by? Positive 3. So 3 times 2 would be 6y minus 39z equals negative 81. Say, combine. Negative 44z equals negative 88. So z equals 2. It's a long one. But we have right now z equals 2. Question. Which part? No, negative 5 and negative 39. I combined these, I added this, and then I just divided both sides by negative 44. Negative 88 divided by negative 44, 2. So now that I have my row echelon, now I just go back and substitute in. Uh-huh.
After you got 2y minus 13,
Mm-hmm.
you combine that with the other top equation.
With this one right here.
And then you just solve.
Yep, to get this.
Okay.
And then now we're just going to plug back in. So I'm going to say negative 6y minus 5 times 2 equals negative 7. So negative 6y minus 10 equals negative 7, right? So if I add 10 to both sides, I get negative 6y equals 3. So what? Not negative 2, guys. Negative 1/2. Yeah, that's a very common mistake. That's why I put this problem on here. So, yes, it's a fraction. Could you convert it to a decimal because it's a terminating decimal? Sure. To find what x is. So you could just say, okay, x minus, you want to say 0.5 to make it easier? Plus 3 times, what was z? 2? Does that equal negative 7, or what does? So x minus, yeah, x minus what? Right, x minus 0.5 plus 6 equals 7. So x minus 5.5 Isn't this 6 minus 0.5?
Oh, yeah.
Equals 7. So minus 5.5.
Yeah.
X equals 1.5 or 3 over 2, 1.5, however you want to write it.
Yeah.
So your ordered triple would be a 3 over 2 for X, negative 1/2 Y, and positive 2 for Z.
I'm confused what you did
After what part?
after the 2y minus 1.
Right here?
So you brought down the
I brought down this, negative 6Y minus 5Z equals negative 7. Then
and then you
I multiplied everything by 3, so these would cancel out.
God, okay.
Yeah.
Thank you.
Yeah, no problem. But guys, again, what can you do with your ordered triple to make sure you're right? Plug it back in. All right, let's do one more of these, then we're going to get to the partial decomposition of fractions, and then we'll be done. This is important for you guys to pay attention to. First equation, is it a positive 1, God bless you,
Yes.
coefficient? Okay, so we're just going to rewrite it. So x minus 3y plus z equals 1. So we're going to go through the whole process again. God bless. And on my second equation, okay, how do I get rid of, okay, I'm going to multiply by negative 2. So we have negative 2x plus 6y minus 2z equals negative 2. X's cancel out. What do we have? 5y minus 4z. Okay, so there's my second. 5y minus 4z equals 0. So now what do I have to do? I want my last equation to say z equals just z. So let's do these top first and the third. X minus 3y plus z equals 1. X plus 2y minus 3z equals negative 1. Okay. Are you guys okay if I just change all the signs? Do I just say minus here? This becomes a minus, and this becomes plus, and this becomes plus. Okay, so my x's cancel out. Negative 5y plus 4z equals, what is it? 2. Okay. So now, I'm trying to get it to say z equals. I'm going to use the green one, right? The 5y minus 4z. So 5y minus 4z equals 0. Well, y's will already cancel out, so that's 0. 4's cancel out, 0 equals 2. Is that a true statement? That 0 equals 2. So when you have something like this, your answer would be that there's no solution. That is a possibility. What happened if you came out to an answer and it was 0 equals 0? That would be infinite, correct. So just be aware, guys. That is a possibility. All right, next thing we're going to talk about, again, this is foreign to most of you. It's not ridiculously hard, but there is a lot of work that goes into it. We're going to take this rational expression. Rational expression just means a big fraction. And we are going to partially decompose it. We're pulling it apart. If something is decomposing, it's pulling apart, essentially. Yes? Okay? These two slides are explaining it to you, God bless you, in God bless you words. If you see this here, do you notice how this is the entire denominator of our rational expression? So what they did to break it apart is separate each piece of the denominator gets its own fraction. Everybody see that? Okay. So then we're going to do some algebra once we get to that point to put it all back together, or to pull it apart even more. Again, this is what this all says. I'm going to show you. It's easier that way. First thing that I would do, because this is just me, you're going to have to do it throughout the process. And this process is the same every single time. So once we do this 1 or 2 times, you're going to be like, okay, wait, this isn't that bad. The first thing you need to make sure is that the denominator is factored. Is it already factored? Yes. So I'm going to tell you, the first thing I want you to do is tell me what the zeros are of the denominator.
3 and negative 5.
X equals 3 and x equals negative 5. You're going to need that in a second. But the way that we pull apart or we decompose, we're going to put this an equal sign. And we're going to decompose. We're going to pull it apart into two separate fractions. What's the denominator going to be of the first fraction? X minus 3. Perfect. And what's the denominator of the second one going to be? X plus 5. We just took this denominator and pulled it apart. Right? Agreed?
Yep.
Now we're just going to use the letter A. I want you to write, this is A sub 1. This is A sub 2. That's how we're going to figure out what our numerator is going to be. Now, the way that I have this set up, do you guys agree that there's a rational expression on the left-hand side and there's one on the right-hand side of the equal sign? Okay, I want their denominators to be equivalent. So this is our denominator. If this one was 2 and this was 3, what would the denominator over here be? 6, correct?
Didn't we do this last one?
Probably. Some of you might have. Some of you may not have. So what would a common denominator be between x minus 3 and x plus 5?
X squared.
No. Don't FOIL them back together. This is our common denominator. Right? So this one has the x minus 3. What piece is it missing?
The X plus 5.
The x plus 5. So what you do to the bottom, you do where? Every single time, it's going to be the same thing. So over here, this one has the x plus 5. What's it missing? So if you multiply the bottom by x minus 3, then you have the top by x minus 3. Everybody agree with me? So now look. Look at each side of the equal sign. Do they all have the same denominator? So now we can just cross them off. It's like they're not even there. So we have this equation. We have 6x plus 14 equals a sub 1. Michelle, you can go now. X plus 5 plus a sub 2, x minus 3. And all we're going to do is solve this equation 2 times. We're going to plug in the zeros. We're going to plug in a 3 the first time, and we're going to plug in a negative 5 the second time. This process is the exact same every single time you do it. So over here, I'm going to plug in x is 3. Okay? So we have 6 times 3 plus 14 equals a sub 1 times 3 plus 5 plus a sub 2 times 3 minus 3. So just simplify. What's 6 times 3? What's 18 plus 14?
32.
So 32 equals, what's 3 plus 5? So this is 8 times a sub 1. And then what happens over here in my parentheses? What's 3 minus 3?
0.
So it's just going to cross out. So if I solve this, divide both sides by 8. And my a sub 1 equals 4. You guys with me? All right, I'm going to do the exact same thing, but instead of plugging in 3 this time, what was the other 0 I want to plug in? Okay, so x equals negative 5. Just remind yourself. So again, 6 times negative 5 plus 14. Right here. So a sub 1 times 5 minus 5? Or is it negative 5? Negative 5 plus 5, right? And then plus a sub 2, negative 5 minus 3. Agreed? So if I simplify this, it's negative 30. What's negative 30 and 14? Negative 16 equals, what happens with negative 5 and positive 5? It cancels out. So I'm left with, what's negative 5 minus 3? Negative 8, a sub 2. Divide both sides by negative 8, and I get a sub 2 equals 2. So now you guys are like, well, okay, what big deal. Now what do I do? Then we go back to the original. Remember when we split it apart? And we had a sub 1 over x minus 3 and a sub 2 over x plus 5? You just put it there. So you have 4 over x minus 3 plus 2 over x plus 5. Shh, girls. That is this decomposed. Now some of you are like, wait, huh? how do you know? How do you leave feeling, okay, I did this question right? Well, let's check it. What would a common denominator, guys, be between x minus 3 and x plus 5? X minus 3, x plus 5, right? So I'm going to go back to my answer. I'm going to say, well, my first fraction has the x minus 3. What's it missing? So if I had 4 times x plus 5 plus my second fraction has the x plus 5, what's it missing? The x minus 3. So if we simplify this, I have 4x plus 20 plus 2x minus 6. What's 4x and 2x? What's 20 and negative 6? Is that what we started off with? Yeah. Let's do another one. It's not ridiculously hard. The process is the exact same every single time. The next one we do, you guys are going to go through it a little quicker because you're like, oh, wait, okay, this makes sense. I'm almost done. Today was long, I know. I'll put the teacher copy. Next period when I do this, I'll do it as neat as possible. I'll do a teacher copy. All right, so let's go start from the beginning. First thing I told you guys to do, make sure the denominator was factored, which it is. So what are the two x's that you're going to plug in? Positive 2, good, and 5. Agreed? At some point, we're going to do that. So when I pull this apart, when I partially decompose it, as we'll say, what are my two denominators? The first one is going to be x minus 2, and the second one's going to be what? X minus 5. Perfect. And then I'm just going to put a sub 1, a sub 2. If I had to combine those two denominators, which are already done for us, the x minus 2 is missing what? This first fraction, x minus 2 is missing what? The x minus 5. The second denominator is missing what? The x minus 2. So the top gets the x minus 2. Now that all of them are the same, what can we do with them? Cross them out, right? So now I'm going to rewrite my big equation. X minus 14 equals a sub 1 times x minus 5 plus a sub 2 x minus 2. Agreed? Now what's my next step? What am I going to fill in? What am I going to plug in? Okay, I'm going to plug in 2 for one of them. And then what am I going to plug in the other one? Perfect. Is this as hard as it seemed like it was a minute ago? No, same thing every time. So I have 2 minus 14 equals a sub 1, 2 minus 5, plus a sub 2, 2 minus 2. What's 2 minus 14?
Negative 12.
Perfect. And then I have negative 3 a sub 1. Agreed? What's going to happen with 2 minus 2? Cancels out. So divide by negative 3. A sub 1 equals 4. Same exact thing on the other side. I have x minus 14 equals a sub 1 times 5 minus 5 plus a sub 2, 5 minus 2. Whoops, I forgot to put a 5 there. What's 5 minus 14? Negative 9 equals 5 minus 5 does what? So then I have 3 a sub 2. Divide both sides by. And a sub 2 equals negative 3. So if I'm going to write my partially decomposed fraction. Okay, so what's my answer going to look like?
It's going to be
4 over.
x minus 3.
Perfect. Plus.
Negative 3 over x.
Good. Could I have written that as minus 3 over x minus 5?
Yeah.
Right? Same thing. And how do we check? Okay, if I was going to have a common denominator, it would be 4 times, it has the x minus 2, what's it missing? X minus 5. Plus, negative 3 has the x minus 5, what's it missing?
X minus 2.
X minus 2. So you have 4x minus 20 minus 3x plus 6. 4x and 3x gives me x. Negative 20 and 6 is 14. What do we start off with? We're so smart. Is this like, oh my gosh, the hardest thing you've ever seen? No. Is it a pain in the butt? Yes. I'm going to set this one up for you. I'm not going to finish it. Yeah, sure. What's different here? Is the denominator factored? No, let's factor it real quick. It would be x times x squared minus 4, right? Which becomes x plus 2, x minus 2. So now when you pull it apart, how many fractions are you going to have? 3. Right? So we're going to go here. A sub 1 is going to be over x. A sub 2 is going to be over x plus 2. And a sub 3 is going to be over x minus 2. And then we go through the same process, guys. The first one has the x. It's missing x plus 2, x minus 2. This one has the x plus 2. It's missing x and x minus 2. This one has the x minus 2. It's missing x and x plus 2. So this would all cancel out, and you would just solve using x squared plus 12x plus 12 equals. So this would be a times x squared minus 4 plus a sub 2 times x squared minus 2. You can leave it if you want to in factored form. Plus a sub 3 x squared plus 2x. And then what are the x's that I'm going to use? What 3 x values am I going to use? If I was going to solve those. So I'd have negative 2, positive 2, and
0.
Yep. So you just plug it in 3 times. That's it. You'll find a sub 1, a sub 2, a sub 3. All right, super long lesson today. I know. Tomorrow